I just thought I'd do a few more examples of Lewis structures, some of the ones that were on the homework that you guys can just like see the thought process and figure out, like see the puzzle that goes on when you're trying to figure it out. Basically, one of the ones on the homework that got a little tricky once there was 3 atoms is HCN. Obviously, hydrogen has, so first thing you want to do when you do Lewis structures is figure out the number of valence electrons each one has. So hydrogen has 1, carbon has 4, and nitrogen has 5. And basically, if you were to show that out legit with like the Lewis structures before they're bonded, hydrogen would just have 1 in its valence. Carbon would have 4, so completely surrounding it. And then nitrogen would have 5. 1, 2, 3, 4, 5. And the fact that it has 2 together, this is a lone pair, and it just means that they're unbonded and that orbital is filled. That side is filled, so it's going to have a lone pair. So basically what you do now is that now you know that hydrogen just needs to bond to one more thing. Carbon needs 3 more bonds, and nitrogen needs 3 more bonds. So basically, you just need to figure, in most cases, carbon is going to be the central atom. Otherwise, it's the most electronegative atom. That's the central one. So first we want to put carbon in the middle, and it's going to bond with hydrogen once so that they both get their stable. And then it's going to bond with nitrogen 3 different times so that they all get their stable 8. But nitrogen also has that lone pair, don't forget, because if you total up, that's the same amount of electrons up there down here. So now you can change all these dots to bonds. So you can just do H is bonded to C, which is triple bonded because there's 6 dots, to N. So one line equals 2 dots. And then, yeah, the lone pair is in a bond, so you just leave those as dots. And basically, what ends up happening is then a lot of people had questions about the electronegativity difference between the two. You would find the electronegativity difference between the two by just finding the electronegativity difference between carbon and hydrogen, and then between carbon and nitrogen. And basically we're going to find out is that nitrogen and carbon are going to have a really big electronegativity difference. Like there's going to be a lot more negative over here, and it's going to create this dipole moment. And that's why the whole molecule is actually polar in general, because nitrogen is so electronegative and pulls the electrons towards it. And that's just the dipoles canceling out. And then you have a general dipole going towards the one that's more electronegative, if that makes sense. Ooh. Yes.